Okay, so let's look at how to balance an oxidation reduction reaction in basic solution. So the example we'll use is that aluminium metal is oxidized in aqueous base with water serving as the oxidizing agent. The products of the reaction are aluminium hydroxide and hydrogen gas. And then we need to write a balanced net ionic equation for this reaction. So let's start with an unbalanced equation, which is, we're told, solid aluminium metals, in other words solid aluminium, is oxidized by water. It says water serving as the oxidizing agent. That will be a liquid to form this complex. So this is called a complex. It's a metal complex for -1. This is of course solvated, and we have hydrogen gas. Okay, so this is not balanced yet. We need to figure out how to balance it. So the approach we use is the half reaction method, and in the half reaction method we write down what the oxidation half reaction is and the reduction half reaction. So for that, we need to figure out what is being oxidized, and we're already told water serving as the oxidizing agent, so it implies that aluminium is being oxidized. So everywhere where you see aluminium in the reaction equation, we then say aluminium, solid, forms this aluminium complex, aqueous. Right, that's first step. Second step, the reduction one. So water is being reduced. Water, liquid, gives hydrogen gas. Now you can already see, doesn't make sense. Where's the oxygen gone? Where's the OHs for the aluminium? The idea is just to split the big reaction, the big redox, into its oxidative and reduction half reactions. And now we need to find a creative way to balance these half reactions. So it's easier to balance the half reactions than trying to do it for the overall one in one go. The first thing that we need to add to the first thing that we can note is we're told it's in aqueous base. So we have a basic situation and a basic situation. In a basic situation, you will of course have hydroxides. So basic solution implies there's OH minuses in the vicinity, which you can use in some way or form. So what do we need in terms of aluminium hydroxide? We will need at least 4 hydroxide anions. So let's say here plus 4 OH minuses. All right. So we sorted out, we've got aluminium, we've got hydroxide. So at least now we have mass balance. So I like to keep a little checklist. So I'll make it here at the bottom. We're going to check the mass. We're going to check the charge. We're going to see if we can simplify. And we need to ensure we have the phases. Oh, goodness. Okay, so we've balanced the oxidative half reaction for mass. Because we have 4 and 4, 1 aluminium, 1 aluminium. Cool. And this is of course in aqueous solution. What do we do with water? Now, water on the left-hand side and hydrogen on the right-hand side. So the only thing that we can introduce where oxygen is present is OH groups. So OH minus. And then how many hydrogens do we have? Well, we have 3 now and 2 on the left. We have 1 oxygen, but we need to balance the hydrogens. So the only thing that we can, or the best thing to do with the hydrogens is we can add a 2 there, add a 2 there, so then we have 4, and we have 4, and we have 2 oxygens. So that mass balances that equation. Okay, so the question is, do we have mass balance? Yes. We've balanced the mass. Next question is, let's use red. Is the charge balanced? That is the next one, right? Yeah. Is the charges balanced? Okay, so let's look at the oxidative half reaction. What is the charge on the left-hand side? Well, it is 4 times -1, and on this hand, on the right-hand side, it's just -1. So what is present in an oxidation or reduction reaction that we can use to balance the charge? Well, it's electrons. So if we have -4 on the left-hand side and only -1 on the right-hand side, that means we need to add at least 3 electrons on the right-hand side. Now we have -4 and -4. In a similar sense, on the reduction half reaction, we have 0 charges on the left-hand side, and we have 2 negative charges on the right-hand side, so -2. So again, the way we fix that is we add 2 electrons here. Okay, so are our charges now balanced? Yes, so we can go check off that on our list. Now we need to sum these two to get our overall equation. But we run into a small issue, meaning that we have 2 electrons and 3 electrons. So we need to balance the electrons in the final equation, because that's the only thing that really will need to be balanced. Everything else will be happy because it's like it was at the beginning. You can also look at it in the perspective of that we have 2 hydroxides, and there we have 4 hydroxides. So what do we need to multiply these equations with to get that right? So we have 3 and we have 2. The common denominator between 3 and 2 is 6. So in other words, we multiply this equation with 6 divided by 3, which is commonly known as 2. And we multiply this equation by 6 divided by 2, which is known as 3. And then we sum them. So 2 aluminium solid. Why? Because of that 2 we have there. We multiply everything in this equation with 2. We also have from that equation 8 OH minuses in aqueous solution. Okay, so that's the oxidation half reaction. Let's move to the reduction one. The reduction one has then 3 times 2 water, so that's 6 water. Plus 2 times 3 electrons, so plus 6 electrons. Right, so that's the left-hand side. On the right-hand side, we have 2 of these complexes. So 2 of them in aqueous solution. We will have 3 times 2, so 6 electrons. And then we have plus 3 hydrogen gas plus 6 OH minus aqueous. Of course, there needs to be an aqueous here. Okay. So now we start identifying things that are both on the left and the right-hand side of the equation so that we can cancel them. So we have 8 hydroxides. And on this side we have 6 hydroxides. Other things that are equal or are on the left and the right-hand side We have 6 electrons and we have 6 electrons there. Okay, so we can simplify the equation. There's no aluminium, so the aluminium stays. The hydroxides, there's 8 on the left and 6 on the right. So that means if we take off 6 of both of those, we have 0 on the right, and we remain with 2 on the left. Water, there's that much. So there's 6 waters. It appears only on the left-hand side. The electrons, there's 6 and there's 6. So that cancels out. There's no electrons on either side, which it should be, because we balance the equations according to the number of electrons. We're trying to get the same number on the left-hand side and the right-hand side so that we have charge balance in the overall equation. Right. We have the 2 aluminium complexes, OH4 minus aqueous. The electrons are gone, the hydroxides are gone, so we're only left with the 3 hydrogens. All right. So that is our final equation, because we can see there's nothing on the left and the right hand side that we can cancel anymore. All are unique species. So we've simplified. We just need to check all the phases. So aluminium solid, so the aluminium metal. The hydroxide base needs to be aqueous. Water is always a liquid. Aluminium hydroxide is an aqueous solution, and hydrogen is a gas. So we've checked that. So you can do your checklist there. It should be, I find that quite helpful to have the checklist as such. Okay. I think that's where we end for this video. I'll discuss the classifying of reactions in the next one. All right, thank you for watching.